Good morning, ladies and gentlemen. I, Hamajam Sheikh, PhD student from University of Karachi, will be presenting my research paper on Big Data Management in Connected World of Internet of Things. Let us start with the presentation. The Internet of Things and Big Data have made the leap to turn into a mainstream issue and maintains broad-level priorities. Both IoT and Big Data are continuously creating headlines all over, drawing a huge amount of research interests and highlighting unique challenges. This growing recognition is due to the intersection of both technologies with tremendous scope for business analytics and the perspective that still remain unexplored. Every day, industrial machines, health monitoring systems, sensors and devices connects to the internet and exchange information. The future of IoT will be extremely populated by huge quantity of heterogeneous network embedded devices which will be producing a deluge of data. As businesses gets on new IoT projects and tries to extract valuable information from the enormous data volumes, a novel data management approach is called for. Conventional database management techniques and analytical methods fail to provide precise facility to handle the diverse data constantly flooding from numerous sources, which are untold. This paper inspects the complex and fast-moving data of IoT and the existing position of data management techniques and challenges in storing and analyzing it. These are the keywords which are related to my research paper: Internet of Things, Data Analytics, Big Data Technology, Smart and Connected Things. Then let's start with the introduction. Technological evolution has transformed the way information was being accumulated, handled, evaluated by conventional processing system. The whole process today's era is executed automatically. With the merger of different smart technologies such as RFIDs, wireless sensor networks, complex event processing, real-time monitoring, and communication with the physical world has become possible. The improvement in networking technique and information processing system have encouraged an advanced kind of an internet structure called Internet of Things. The IoT is an expansion of connectivity into broader range beyond just machine-to-machine communication, which facilitate better data insight and analytics. Numerous amount of data known as big data is being generated by IoT. Big data analytical techniques are required to analyze the flood of data from the physical resources to facilitate future internet services. The influence of Internet of Things on human is still big question, and it do demands consideration and how it plays a significant role in a smart world. The future of internet technologies relies in data and its analysis. Today's internet is connected by various objects and devices which are transmitting the assembled information for the analysis. The objective is to find out the emerging trends in the data which can have the positive impact on society. The IoT have revolutionized the internet by connecting the physical world to the web through numerous sources, resulting in a deluge of data which require proper process for collection, processing, storage and analysis. As we can see in the figure, we have Internet of Things, which include various kinds of nodes, sources. We can say, for example, we have cameras, we have smart homes, we have music files, we have health monitoring system, we have transportations, we have other automation tools which is being connected to the internet these days. To manage the data generated effectively and intelligently, if extensive research and development is required, appropriate perception of accumulated data can bring about an enhanced understanding of the world we live in. However, this disruptive technology requires new infrastructure due to the dynamism of the network participant as well as influx of heterogeneous data. Most advanced automated data analysis methods known today might fail to deal with the flood of the data that starts flowing and growing by minute. Data strength-centric and engineering efficient, energy efficient IoT database management approaches and challenges are also reviewed in various research work. Some offer centralized cloud-based solutions. Data gathered from various sources for analysis may possibly present a comprehensive view on the interaction and relationship between the physical entities, facilitating the conversion of raw data and information into a long-term knowledge and perception. Our paper surveys the associated work, research challenge, and present effort for the management of data in IoT. This is the layered view of IoT. IoT infrastructure comprises of four layers: sensing layer, networking layer, middle layer, and application layer. By sensing layer, we mean the things, the technologies such as infrared, GPS, RFIDs, cameras, low power wireless. Then gateway layer include the public-private network, wireless networks. IoT management services include data security, data management, and other data processing and analysis techniques and policies. Whereas the last layer is the application layer. It includes different kinds of IoT application domains such as healthcare, smart transportation, smart cities, etc. Let us briefly. The future of IoT will be extremely populated by huge quantity of heterogeneous network embedded devices which will be producing a deluge of data. As businesses gets on new IoT projects and tries to extract valuable information from the enormous data volumes, a novel data management approach is called for. Conventional database management techniques and analytical methods fail to provide precise facility to handle the diverse data constantly flooding from numerous sources which are untold. Then we have a middle layer which integrates several functions which are critical in an IoT infrastructure. It includes management and communication between devices, data processing and security. It offers interfaces for the application by abstracting the complexity of sensing and networking layer. Then application layer provides end-user domain-oriented IoT applications. Then let's start with the introduction. Technological evolution has transformed the way information was being accumulated, handled, evaluated by conventional processing system. The whole process today's era is executed automatically. With the merger of different smart technologies such as RFIDs, wireless sensor networks, complex event data characteristics in IoT, it is anticipated that by 2020 there will be around 20.8 billion things operational globally. IoT data is complex and fast moving. Organizations need to extract more information for the swelling data volume and seek for new data management approaches to handle the flood of data which is from the untold sources. In a survey, Aberdeen Group estimated IoT organization capability to accumulate, integrate, and analyze data generated by different devices. The investigation discovered the area where organizations struggle to expect to progress. For example, average volume of data grew 30% every year in an IoT organization, with some organization complaining about insufficient data analysis capability and resulted failed to make timely decisions. Embedded devices with sensing technology are more affordable than ever before and are connected over internet for continuous data transmission, accumulating data which is also diversified. Current IoT organization lacks the analytical tools and infrastructure required to handle non-traditional data formats such as geospatial and unstructured data. Policymakers are unable to convert this data into a meaningful insights and are seeking procedures which will allow them to process, store, and analyze this information. Secondly, IoT organization also fails to make timely data-driven decision because they are unavailable to take rapid action on this fast stream of data. So, IoT organization requires automated data analysis and management resolutions that yield rapid decisions. No matter how many endpoints are concerned, IoT is rapidly affecting big data three characteristics, which are volume, velocity, and variety. The data collected by the connected things have following characteristics. Data variety, data is heterogeneous, obviously. We have unstructured and semi-structured data. For example, we have social media tweets, metadata, health record, audio video streaming, images. Organization faces issue in performing data mining and machine learning analytics over the data gain. Data volume and velocity, the lack of data due to real-time exchange of data and information by heterogeneous things connected over a network. Efficient data filtering, compression, and storage methods are required for data processing. Society. The IoT have revolutionized the internet by connecting the physical world to the web through numerous sources, resulting in a deluge of data which require proper process for collection, processing, storage, and analysis. As we can see in the figure, we have Internet of Things, which include various kinds of nodes, sources. We can see IoT application domain. It is an attractive element of every aspects of our life. It examples extends from smart connected cities to healthcare wearables. IoT applications are intensifying the comforts of our life by controlling and simplifying routine work and personal tasks. Data characteristics in IoT, it is anticipated that by 2020 there will be around 20.8 billion things operational globally. IoT data is complex and fast moving. Organizations need to extract more information for the swelling data volume and seek for new data management approaches to handle the flood of data which is from the untold sources. Wearable and healthcare. Wearable IoT is an extremely big domain, broadly covering the fitness, health, and entertainment requirements. The IoT wearable technology requirement is to be extremely energy efficient, low power, and small size. For example, a wearable device which is sensing patient data, medical condition, and sending it to the server. Then we have automotive transportation. In automotive and transportation domain, IoT offer various solutions for smart management. For example, smart car parking. It can save time of the driver, fuel costs. It can provide him detail regarding the traffic jams. Another example is of Google self-driving car society. The IoT have revolutionized the internet by connecting the physical world to the web through numerous sources, resulting in a deluge of data which require proper process for collection, processing, storage and analysis. As we can see in the figure, we have Internet of Things. IoT management techniques and challenges. IoT development and adoption is rapidly accumulating the data, and experts warn that the present river of unstructured data will shortly convert into a flood. So we should get ready before the flood arrives. There are numerous methods and tools for solving several IoT data management challenges. A recent survey recommended concerns that most suggested techniques could lead to data management overloaded, inadequate for coming torrent of data. Conventional centralized databases will always play a part in analytics. However, IoT enterprises persist to gain momentum and moving from central data repository towards edge of the network. IoT organizations have automated the data capturing process by embedding the data management into the device and sensor, which are generating the data to expedite a smooth and stable stream of information. Therefore, data is handled as soon as it is produced, causing good control on the real-time data feeds. However, data generated by our IoT sensor readers can be false, also known as a dirty data, signifies in four forms: false positive, false negative, invalid, and redundant. By false negative and false positive, data occur due to the obstruction between the sensor and the environment, which may result in invalid data showing deviation from the original ranges. Data redundancy is caused because too many sensors are covering the same object. Data management at this stage involves data cleaning, which is elimination of false, incomplete, and duplicate data, and solves data quality issue in the database system. Techniques to data cleaning include spatial and temporal granular approach and stream data cleaning. Well classified and filtered information is easier to analyze. Obviously, it eliminates congestions at the central servers, protect data bases from getting flooded with the data with extra volume and velocity. These are the challenges which is collectively faced by an organization. It was a survey. The graph basically presents three kinds of a major issue, which is number one is the data capture issue, then we have data analysis, and then action on the data. 36% organization complains that they have difficulty in capturing useful information, whereas 25% says data is not captured reliably. They are lacking the technologies which can effectively collect the data. Then 19% says data is captured too slowly to be actionable. They demand real-time action taken. Then we have data analysis. 40% says too much data to be analyzed effectively. There's a deluge of data. Then 30% says analysis capability are not flexible enough to ask the question we want. So they are lacking the skills to analyze the data. 26% says data is analyzed too slowly to be analyzed, and they are unable to understand the data on time so that they can make effective decision. 27% say we are not sure what question to be asked, whereas 24% says business processes are too rigid to allow us to act on the analysis. Organizations with IoT aspiration must invest in analytics at the edge to facilitate enhanced data management. Next stage is to process the accumulated clean data which can be treated as primitive event. Data delete with complex semantic from heterogeneous storage is a big challenge for IoT data processing. Ontology-based semantic event processing for IoT is a significant tool to build the idea and association between the things in IoT. IoT application domain. It is an attractive element of every aspects of our life. It examples extends from smart connected cities to healthcare wearables. IoT applications are intensifying the comforts of our life by controlling and simplifying routine work and personal tasks. Whereas data stream model algorithm process the streams of data which is input in a sequence without explicitly storing it. Classical big data stream processing system consists of Twitter Storm, Yahoo S4, LinkedIn, Kafka. Cloud computer is another big platform for big data analytics. Technology like SQL can transport real-time analytics on immense dataset and effectively compress a database into a small server processing. What are the key outcomes of the current state of IoT data? The present achievement of the IoT organization analytics are still on set. Certainly, these two fields, big data and IoT, can create new possibility and will have a long-lasting impact. Now, it is expected that average organization data will double within the 3 years. Therefore, data is mounting and analytics demands are swelling up. As the deluge of information intensify, decision maker calls for add-on capability and faster access. The current capability of IoT organization analysis is insufficient and time to decision is not improving. Wearable and healthcare. Wearable IoT is an extremely big domain, broadly covering the fitness, health, and entertainment requirements. The IoT wearable technology requirement is to be extremely energy efficient, low power, and small size. For example, a wearable device which is sensing patient data, medical condition, and sending it to the server. Conclusion: the big data and IoT share a strongly knitted future. For the development of Internet of Things, big data is prerequisite. IoT is definitely creating new business opportunity, increasing customer experience, accelerating growth of business and performance, providing enhanced operation and machine quality and control, as improving safety. Without appropriate data assortments, business will be deprived of the opportunity to classify the information impending from the built-in sensor.